In this lesson, we will build an intuitive picture of state functions and path functions in chemical thermodynamics, aligned with NIOS and CBSE curricula. We will compare what depends only on the state of a system and what depends on how the system changes from one state to another. First, let us define each idea clearly. On the left are state functions. A state function depends only on the current equilibrium state, not on the path taken to reach it. On the right are path functions. A path function depends on the specific process route between states. A key property of any state function is this. For two states, A and B, the change in a state function x is x sub b minus x sub a. This difference depends only on the endpoints, not on how you got there. Let us visualize this with a pressure-volume diagram. We mark state A and state B. Now we draw two different paths from A to B. One path goes in 2 steps, and another path curves smoothly. The endpoints are the same. So any state function change like delta U, delta H, or delta S will be identical for both paths. But the heat and the work Q and W can be different for the two paths. The reason heat and work can vary with path is captured by the first law of thermodynamics. It states delta U equals Q plus W, using the chemistry sign convention, where work done on the system is positive. Since delta U between the same two states is fixed if the work term changes with path, the heat must adjust to keep the sum constant. Now, an illustrative example used often in CBSE and NIOS. Consider heating 1 mole of an ideal gas from temperature T1 to temperature T2. For an ideal gas, the change in internal energy depends only on temperature, so delta U equals NCV times T2 minus T1. But the heat absorbed depends on the path. At constant volume, Q sub V equals NCV times delta T, which equals delta U. At constant pressure, Q sub P equals NCP times delta T, which is different because the gas also expands and does boundary work. Let us visualize these two common paths side by side. Recap. State functions like U, H, S, P, T, and V depend only on state. Their changes between two states are path independent. Path functions like heat and work depend on the process route, so Q and W can vary for different paths, even if the endpoints are the same. The first law ties them together. Delta U equals Q plus W. One more idea that students often ask: if a system moves in an electric field from a higher potential to a lower potential, then VA minus VB is positive. This mirrors the state function idea. Potential is a state function, so VA minus VB depends only on the endpoints and equals the drop in potential. Great work! Keep these pictures in mind as you solve thermodynamics problems. Always ask, is this a state function or a path function? That question guides how you compute changes and what information you need.